Betelgeuse, one of the most famous and mysterious stars in the night sky, continues to defy the laws of stellar physics and captivate astronomers. Located in the constellation of Orion, approximately 650 light-years from Earth, Betelgeuse is a red supergiant that belongs to a class of highly evolved stars far more massive and luminous than our Sun. However, despite its imposing presence, Betelgeuse is preparing to end its life in a spectacular and cataclysmic way: a supernova explosion. While this is a common fate for very massive stars, what makes Betelgeuse even more fascinating are the numerous mysteries surrounding its behavior, which seem to challenge our understanding of dying stars. Betelgeuse is known for its sudden fluctuations in brightness. Although red supergiant stars like Betelgeuse are notoriously variable, the brightness oscillations of this star are particularly dramatic and unpredictable. In December 2019, the star experienced a drastic decrease in brightness, losing about two-thirds of its luminosity within a few weeks. This decline caused a wave of concern among astronomers, who initially feared that the star was about to explode as a supernova. While the idea of an imminent explosion was not entirely unfounded, more recent observations revealed that the phenomenon was the result of a massive stellar eruption, an event that ejected material into the surrounding space, creating a dust cloud that temporarily obscured the star. These episodes of intense activity are not uncommon for red supergiants, but the speed and intensity of these events in Betelgeuse are extraordinary. Betelgeuse's brightness oscillations are periodic in nature, but they are not straightforward to interpret. The star exhibits a roughly 400-day brightness variation cycle during which it expands and contracts, but astronomers have recently discovered the presence of longer cycles, lasting about 6 years. These long-term changes have led to theories suggesting that the star might be influenced by a companion celestial body, perhaps a smaller star orbiting Betelgeuse at a relatively close distance. An intriguing aspect of Betelgeuse is the possible presence of a companion star. While it is known that many stars form in pairs or multiple systems, the presence of a companion near Betelgeuse could explain some of its observed characteristics, such as the long-term brightness fluctuations and the mysterious structure of its eruptions. Recent studies and theoretical models suggest that the companion could be a relatively small star, around 1.7 solar masses, located just 2.43 radii from Betelgeuse. This makes the companion extremely difficult to detect, as its brightness is far lower than that of the red supergiant and may be obscured by Betelgeuse's intense radiation. Astronomers have begun carefully studying data from advanced telescopes to try to identify this companion, which could explain many of the anomalies observed in Betelgeuse. The companion might not be a normal star but rather a brown dwarf, a type of celestial object that lacks sufficient mass to initiate nuclear fusion in its core yet still emits a small amount of radiation. A brown dwarf could be challenging to detect due to its low luminosity, but it might be responsible for some of the periodic events observed around Betelgeuse, such as its brightness variations. Some astronomers suggest that the companion star might also be responsible for the shorter and more intense brightness fluctuations that Betelgeuse exhibits. When the companion moves away from Betelgeuse, the star's brightness increases, whereas when the two stars come closer, the overall brightness decreases. This type of interaction between two stars could explain the cyclical variations in brightness and the complexity of the observed cycles. Another mystery that makes Betelgeuse fascinating is its rotational velocity. Red supergiant stars, which are in an advanced stage of their evolution, tend to rotate very slowly. This is because, during their expansion, their rotational speed gradually decreases. However, Betelgeuse behaves anomalously compared to other stars in its class. Observations conducted with the ALMA telescope have revealed that Betelgeuse rotates at a speed of over 5 km per second, a value much higher than expected for such a star. One possible explanation for this high rotational velocity is that Betelgeuse may have engulfed a companion star in a catastrophic event approximately 100,000 years ago. In this scenario, the smaller star would have transferred its angular momentum to Betelgeuse, accelerating its rotation. This phenomenon, known as stellar cannibalism, has been tested through computer models and found to be plausible. In fact, astronomers have observed shell-like structures in the material ejected by Betelgeuse, which seem to confirm the idea that the star assimilated another celestial body in the past. Such an interaction would not only accelerate the star's rotation but could also explain its irregular pulsations and brightness variability. Betelgeuse's life is nearing its end in a cataclysmic explosion, the supernova. A supernova occurs when a massive star exhausts its nuclear fuel and can no longer support its structure against gravitational collapse. Betelgeuse is a star with a mass approximately 20 times that of the Sun, and when it depletes its fuel, its core will collapse, triggering a reaction that will result in a Type II supernova. This event will not only mark the star's end but will also have significant effects on its surrounding environment. A supernova explosion can generate shockwaves that sweep through the surrounding space, enriching the interstellar medium with heavy elements like iron and carbon, which will later be used to form new stars, planets, and perhaps even life. Supernova explosions like Betelgeuse's are also crucial for our study of dying stars, as they offer one of the few ways to observe the collapse of a massive star in real time. Although the exact moment of Betelgeuse's explosion is still unknown, it is estimated to occur within the next few 100,000 years, a relatively short period in cosmic terms. Betelgeuse offers astronomers a unique opportunity to study stars on the brink of supernova explosions. Its brightness fluctuations, anomalous rotational velocity, and possible connection to a companion star raise important questions about the lives of massive stars and the processes leading to their death. Every new discovery about Betelgeuse not only enriches our understanding of this particular star but also provides vital clues for understanding the death of similar stars throughout the universe. Thank you for watching. Leave a like, subscribe to the channel, and activate the notification bell so you don't miss future videos.